Hello, I'm Jim Kohler with the Product Innovation Group of International Paper. The CD you're viewing right now is titled Anatomy of a Web. Why Anatomy of a Web? Well, we're going to dissect the web offset process so you have a good understanding of how this system works. In the printing industry today, there are three types of web. The first is what I like to call a baby web. These are your small 17-inch to mid-20-inch range presses. They generally come in two configurations, either cold set or UV. What's cold set? Well, cold set inks are like sheet fed. They dry by oxidation or air and absorption into the structure of the paper. UV is a little bit different. These inks are made to react with ultraviolet light. So the press will have UV lamps on the printing press, so when the ink passes underneath those lamps, it's set immediately. These presses generally print only one side of the paper at a time. So if you had a 6-color web, you would set your first 2 units maybe up to print the back side of the paper, turn the paper over with what's called turn bars, and then print the other 4 colors on the top side. A classic case is billing. Well, they'll print 1 or 2 colors on the back side of the bill, and then the 4 color on the top side of the bill. The UV presses are becoming very popular because of direct mail. Direct mail, as you know, is requiring a lot more color, a lot more ink. They need to set that up immediately. They haven't got time to let it dry. These presses also have post-press equipment attached onto the press, like punching, perfing, those types of equipment, and then they can go right into a sheeter, or they can print them roll-to-roll if they're going to do maybe some inkjet personalization afterwards. What's your second type of web? This would be the half web. These are a little bit different, though, because these are heat set. What's heat set? Well, unlike the cold set of the UV, we have to put an oven on that press to help dry the ink, because the ink is different. What's going to happen once the printer prints the piece, it goes into the oven. These ovens' temperature range is around 350 degrees, meaning the web temperature is about 250 degrees, depending upon what you're printing, of course. Once it enters the oven, the oven's going to remove the solvents, leaving the ink in a semi-liquid state. It leaves the oven, it goes into what's known as chill rolls. These chill rolls are filled with cold water. They then, because of the heat differential with the hot ink, the cold rolls, they will set the ink immediately. These presses are configured a little bit different than the baby webs also. They're perfecting presses, meaning they're printing both sides at the same time. Your half web can do 8-page signatures, and I'll show you what a signature is in a minute. Presses are set up a little bit different, because once you print, you go into the heat set dryer, you then go through the chill rolls, you then pass a small silicone coater. These coaters will apply a light silicone water anti-static mixture to the sheet. Why do you do that? Well, that is to help reduce the static and let it slip through the folder or sheeter a little bit easier, especially coated papers. Coated papers have a tendency to mark. That reduces the marking properties of it. So now we have an 8-page press. Speeds run up around 1,200 feet per minute. What's the third type? The third type is the full web. These are webs that range in the 32-inch up to 57 inches, depending upon the configuration. In the industry today, most printers will buy either a 38-inch or a 57-inch. What's the difference still, you ask? Well, a 38 press is going to produce a 16-page signature, while your 57-inch is going to produce a 24-page signature. Now, there's a lot of dependencies on this, but this is a generality. Same setup, heat set dryer, chill rolls, silicone coater, folder sheeter combination. Unlike the baby web that basically had a roll back stand, and most of them today will have a dual back stand so they can run continuously. They'll have a little tension controller to help adjust the tension going into the printing units. One side printing, post-press, and then finally into a sheeter or a roll-to-roll configuration. Your big webs are going to be a little bit different. They'll still have a 2-roll back stand. Most of these back stands are known as a zero-span splicer. You'll then go into a tension controller, which controls the tension going into the printing units. Probably 6 printing units. The average press today is going to be a 6-color press, obviously to print the 4 primaries, your black, cyan, magenta, and yellow, and your 2 spot colors. The heat set dryer, the chill roll section, a silicone coater, and finally into either a folder or a sheeter configuration. Why would you do a folder sheeter configuration? Well, for a signature, this signature came off a 38-inch press. As you can see, it's a 16-page signature. 8 pages on one side, 8 on the other. You fold it, you get 16-page signatures ready to go to the bindery for a publication. So if I'm doing a publication, I want to go into a folder to produce a signature. But now I'm doing a direct mail piece. It's a return postcard. I'm going to go into a sheeter to do that. I'm obviously not going to fold it. And by the way, most of these heat set webs today can be configured with punching and perfing also, because the commercial printer of today wants great variability in the types of materials he can print. Okay, we're at the start of the printing process. This press, the Sunday 2000, is configured in a 6-color configuration. Why 6 colors? Well, black, cyan, magenta, and yellow, or as really known as process colors, only replicates about 13,000 colors in the color gamut. That's not a lot when you really think about it, especially today when the computer programs are into billions of colors. Let's say you're doing a corporate piece, and in that corporate piece is a corporate logo that consists of a special blue and a special red, and they really want to match those colors perfectly. We're going to do it on these 2 special units. I could print the blue here and maybe a red there. That would make up the corporate logo. It even gets better because let's say I wanted to print a special blue on the top, but the piece called for a special red on the bottom. I could do that. This is a perfecting press. I can print 2 colors separately, top and bottom. That being said, I could print the corporate blue here, move on, then print the corporate red here. Now we have 4 more units. We're going to print our process colors. Black, followed by generally cyan, followed by magenta, and last, mellow yellow, or I like to call it, or the yellow ink. That makes up the whole process. Why 6 colors? Well, most printers today are going to buy either a 5-color or a 6-color to give them more flexibility in their print jobs. Again, clients today want more color. To do more color, we need to expand the color gamut. That means expanding the press's color gamut, thus 5- and 6-color presses. It wouldn't surprise me in the future you start to see 8-color webs as more and more colors demanded by the clientele. Okay, we're at the start of the whole process. We're at the backstand. Most of your heat set webs today have what's called a 0-span or a 0-speed splicer. This is not a flying splice. A flying splice generally is on your larger presses like your newspaper, your gravure presses. A flying splice makes the splice to the new roll while the new roll is actually rotating. The 0-span or 0-speed does not do that. It makes the splice to the new roll at a dead stop, meaning the new roll is not even turning. How do we do that? Well, in this splicing mechanism, we have what's called a festoon, or what I like to call a squirrel's cage, because the paper is running back and forth on a series of rollers. What that is a lot of leader edge. So when the splice is made, that leader edge is allowed to reduce itself, allowing the new roll to come up to speed. Now what happens is when the new roll is put on, and this particular press is pretty automated, so the operator can cut the end caps off, take the little core chucks out, the press automatically, or the backstand automatically rolls it into position and mounts it on the unit itself. The operator can then make the splice, put the tape on and all that kind of thing, and you're ready to go. Again, this is a 0-speed or a 0-span splicer, very automated. Contained in this unit is also a tension controller. Unlike your older webs, your older heat set webs, the tension controller is a separate unit. This is built in. What's that tension controller do? It wants to isolate all the tension variables so it feeds a constant rate of paper into the printing unit. The tension controller is what's known as draw point number 1. That's an isolation point. And it's reacting with the print unit and the brakes in the backstand. So that tension controller can tell the brake, let up a little bit or apply more brake. Also, there's a web guide device to keep the alignment of the web in perfect alignment going in. Obviously, we don't want the web sliding back and forth as it would throw the print units off. And that's how this works. Again, this is a 0-speed or a 0-span. What's that difference from a flying splice? We pick up the roll from a dead stop. Where a flying splice, both rolls are operating.